Hey guys! So today I'm going to talk about solving first order differential equations using variation of perimeters. In particular, we look at this example where xy dy dx minus cosine x y cubed is equals to x y squared. Oh my god, this is so complicated. Don't worry, you can further simplify it using this form. So now you get dy dx minus cosine x over x y squared is equals to y. This looks familiar, but it's not exactly in the form that we know how to solve. Shift it around, and we get the most common and familiar form that we see. But even so, there's this irritating y squared on the right side that cannot be further simplified. Therefore, we use the replacement v equals to y to the power of 1 minus n, where here n equals to 2. Why do we use this? It's because of one of the problems that we solved in P set 1. So if you don't understand it, please review it right now. And therefore we use v equals to y to the power of negative 1. Using this substitution, we can change the equation to the more common form that we recognize, mainly dv dx minus v is equals to negative cosine x over x. We know that the homogeneous solution v of vh is equals to, using separation of variable, a e to the power of negative x. But what is the particular solution? Here we use variation of perimeters, which is the main subject of today's video. We guess that vp is equals to a, which is a function of x, e to the power of negative x. And therefore, if we differentiate vp, we get v prime is equals to a prime x, e to the power of negative x minus ax, e to the power of negative x. If we do a simple comparison, we know that a prime x e to the power of negative x is equals to negative cosine x over x. And we move e to the power of negative x over, and we get this equation. So we just integrate it. We get a of x is equals to integrate negative cosine x over x e to the power of x dx. I'm not going to do the integration, but you guys can plug it into Wolfram. So we know that vp, the particular solution, is in this form. Remember though, you have to add a constant after solving it. But v is equals to y to the power of negative 1. So if you want to know what is the particular solution for y, we substitute in vp is equals to y to the power of negative 1. And this gives us the final solution. Voila!